In this unit, we're going to talk about a new function called a quadratic function. This one you may have seen before in 8th grade, and you may not have. Okay. First, let's talk about what a quadratic function is. A quadratic function is a U-shape. It is a U-shaped graph called a parabola. And it's in the form of ax squared plus bx plus c. Okay, so it's not linear. When we talked about linear functions, that was y equals mx plus b. A quadratic function is this, ax squared plus bx plus c. So in the same way you've memorized y equals mx plus b for so long, you're going to want to start to memorize this ax squared plus bx plus c. Now, a, b, and c stand for numbers. So when you see an actual quadratic equation, it might look like 2x squared plus 3x plus 7, right? A, b, and c stand for numbers. So that's an example of that. A can't be 0, and the greatest exponent of the variable is x is 2, which means to know if something's quadratic or not, you really just have to notice that you've got an x squared in your equation. If it's got an x squared and nothing higher than that, then it's quadratic. So this is what the shape looks like, this curved red shape. That's called a parabola, it's called a quadratic. There are several main features of a parabola. The first one is called the vertex. That's this point right here. The peak of the curve is called the vertex. Another really important part that goes kind of hand in hand with the vertex is called the axis of symmetry. See this line going straight through here? Now that line is not actually on the graph. It's invisible. Okay, I'm making it a line over to show you that there is an invisible line that goes straight through the vertex, and we call this line the axis of symmetry. The axis of symmetry. And it's always going to be x equals a number when we define it. Okay, always will be x equals a number. It's always an equation. Another main part of a parabola, and this is a main part of most graphs, is this guy right here. Now notice, this is your x, this is your y. So this point right here is where the curve is hitting the y. Oops, sorry, that's not the y. This is the y. This point right here is where the graph is touching the y-axis. So this is your y-intercept. That's the same thing that's in a line, right? When your line crosses the y-axis, it's called your y-intercept. And your last two important features go together. That's this point right here and this point right here. Now these 2 points are crossing at the x-axis, so we call these points x-intercepts. Okay, because that's where it touches the x-intercept. There's also another name for this. It's called a zero. So their x-intercepts and zeros mean the same thing. If I say find a zero, I'm asking you to find where the x-intercept is. Okay. In this particular graph, since it's going down, we call this graph concave down. So this graph because it's pointing down. If I were to put arrows on here, the arrows would point down, so this graph is concave down. Throwing a lot of vocabulary at you here, okay? So now let's take a look at a graph that is not concave down. This graph, if I were to put arrows on it here and here, this graph would be concave up. All the other points here we can find. We can find the 2 x-intercepts, they're right there, or the zeros. We also have the vertex right here. That's that. It's not the peak, now it's the very low valley. So that's the vertex. It's where it starts to curve, go one direction to the other. That's where the vertex is. Your axis of symmetry is this invisible line going through there. And then finally, we have our y-intercept, which is right here. Okay, so let's practice a little bit what that means when we're looking at a picture of a parabola. So the first example says, what is the name for this? And it's pointing to this spot on the graph right here. Well, this spot is along the x-axis. It's an x-intercept. We also call x-intercepts zeros. Okay, so there's another one over here too. These are both x-intercepts, both zeros. The second one, which of the following is a zero? Well, first let's locate the zeros. So I've got one right here, and I've got one right here. This is at the point -3, 0, and this is at the point 1, 0, and that matches letter C. Okay, so -3, 0 is a 0. Now notice that it's got the 0 in the coordinate pair. That's important for later. Number 3, what is the name for this? And the arrow is pointing to this line here. What did we talk about that line being that goes right through that point? That's called the axis of symmetry. The fourth one, what is the coordinate for the vertex? Remember, the vertex is that peak or valley. So there's the vertex, and that coordinate is -2, 4. And that is right here, answer C. So we're just using this vocabulary to be able to label parts of our parabola. Number 5, 4, -2 is an example of what? Well, let's go to 4, -2. That's right here. Well, that's the little valley right there. So that's your vertex. And the last one, this graph does not have a what? Well, it has a vertex, so we're good there. If every parabola has an axis of symmetry, it's just invisible, so we're good there. It has a y-intercept right here, but this graph does not have any zeros. For it to have a 0, this graph needs to connect on this line right here. Does this graph ever touch that line? No. So this graph doesn't have any zeros, and that's okay. Sometimes parabolas don't have x-intercepts, don't have zeros. That's okay. It should have everything else though. So I want us to be able to graph a parabola on our own. And we're going to start with the most basic of graphs of a quadratic, and it's called the parent function. Now, we talked about this with absolute value functions. We had a parent function. It was like the original quadratic, original absolute value, and all the others just moved around. This was the very first unit we did this year. So now we're going to talk about the quadratic parent function, which is this. You might want to put a box around this, highlight this. This is important. Y = x squared. That is the parent. So we're going to make a table of values for this. Okay. Whenever I make a table of values, I always start at -2 and I go to +2, because that way I get a couple negative values, I get 0, and I get a couple positive values. So that's what I always do when I make up my own tables. You'll have to make up your own tables at some point too. Always start at a negative. Don't just start at 1 or 0, because the negatives are important. So now to make a table, here, remember I have to take that x value and plug it into y = x squared. So when I plug it in, or I want to plug in -2, that's going to give me a 4. So when x is -2, y is 4. When I plug in -1, -1 squared is 1, so at -1 it's 1. At 0, y is 0. At 1, it's 1, and at 2, it's 4. This is a really important thing to memorize, and I'm going to put a box around it. This table of values is your parent function. These coordinate pairs, right? These all form little coordinate pairs. These coordinate pairs are your parent. So when we graph this, -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. These 5 points form your quadratic parent function. I would memorize that. It's important. Okay, now that we've graphed it, we've found 5 core points. Now let's answer some questions. Is this concave up or down? Remember, that's which way the arrows would be pointing. So this is concave up. Maximum or minimum is new, but maximum or minimum is asking you to describe the vertex. Well, the vertex is here at 0, 0. Now ask yourself, is that vertex the lowest point on your graph, or is it the highest point? It's your lowest point, so it's a minimum. That's the lowest it can go. That's a minimum value. Your axis of symmetry is the line going right through 0, so we call that x equals 0. It's always an equation of wherever it's going through. Your y-intercept happens to also be right here at the vertex, so your y-intercept is 0, 0. It does have a 0. Also, it's at 0, 0. Now, domain and range, I'm going to refresh your memory. Domain is all those values that go from left to right. So quadratics always have infinity, negative infinity to positive infinity for domain. It's going to go up, it's going to go to the left forever, to the right forever. But your range, your lowest range value is 0, right there. It doesn't go any lower. There's no lower values below that 0. So it goes from 0 all the way to positive infinity. So this is your parent function. This is important. You want to memorize how to graph this, and you want to memorize its parts. Because now when we graph new quadratic functions, we're just transforming the parent. Now, I'm going to show you some tricks here to help make this process much easier. I'm now going to ask you to graph different quadratic functions. Now, notice this one. This is y equals 2x squared, which is different than the one we just graphed, which was just y equals x squared. Now I've got this 2 in here, and I need to make a table of values. Well, I'm really awesome, and I'm going to suggest you use some technology to help you with this. The first piece of technology you have is your calculator. Okay, so if you have a calculator, your calculator has a graphing function. If I can turn this on, there we go. Okay, so here are your steps to graphing on a graphing calculator. Step number 1, hit the y equals button. That's this button right here. It says y equals at the very top. You're going to get a plot. You're going to get this screen. Make sure all of those are cleared out. Okay. Step 2, type in the equation. Well, my equation is 2x squared. So 2, then I'm going to hit my variable button, which is this button right here that has the x, t, theta, and pi symbol. It's right above apps. That'll give you an x. And then to get squared, you just hit that little x squared button. So I typed in my equation, okay? Now what I'm going to do is I'm going to hit graph, the graph button. So I hit graph, and it's going to show me a picture. This is going to show me the picture. Now this isn't quite as helpful right now because I need to be able to plot points, and I can't easily see points from a picture. However, if you now hit the second button, so this yellow button, press the second button, and then you press graph again, it's going to give you a table. And in this table, I can scroll. See how my table starts at -2? I can hit the scroll up button, and I can scroll to where I see -2. Now I've got my table. Now I see that -2 and 8 go together. I see -1 and 2 go together. 0, 0. 1, 2, and 2, 8. You're going to notice that every time you do this, you should see a mirror effect. And what I mean by that, oops, I didn't mean to hit that button. What I mean by that is when you look at your y values here are your y values, right? You'll have this middle value, and then as you go up and as you go down, it's mirrored. It reflects each other. So whatever values you have above the 0 will be the same as the ones you have below. If you don't, then you've done something wrong. So the calculator can easily get this table for you. Now all I have to do is plot the points. -2, 8. -1, 2. Oops, it's -1, 2, sorry. -1, 2. 0, 0. 1, 2, and 2, 8. And I've graphed y equals 2x. Okay. The other way we can do this is a website called Desmos. So this right here is Desmos, DESMOS.com, and you guys all have laptops, so this is, if you don't have a calculator, this is another option. It doesn't do a table as well, but it will let you graph and find points. So you hit start graphing. And you're going to get this blank grid with something to type into here. Now, I want to type in y equals 2x, right? 2x squared. So I'm going to do y equals, and then 2. And then to get my x squared, I'm going to type in the x. And then see this a squared button? If I press the 2 there, that a squared button, it gives me 2x squared. Now this doesn't give you a table of values. However, if you zoom in, you can find these points. So there's 0, 0. There is 1, 1. You can see it crosses at, 1, 2. You can see that it crosses here at -1, 2. And if you keep scrolling up, you can see it crosses at 2, 8, way up here and way over here. So you still get the same points. It's not as great without the table, but you can still graph and you can still find these points to plot using Desmos. That works just as easily, and I'm totally okay with you guys doing that. Okay? So let's graph the other one and then compare the two. So the other one now is 1/2 x squared. So I'm going to use my calculator. I'm going to go back to y equals, and I'm going to clear my old equation. Now I'm going to type my new one in. Now be really careful. That 1/2, you've got to put that in parentheses. Parentheses 1 divided by 2, parentheses. Then you can put in your x and your squared. If you don't put it in parentheses, it's not going to give you the right graph. Okay, now I'm going to hit graph. Well, if it's going to work, there we go. It's going to graph it for me. And then I'm going to get my table by hitting second, graph, and I get my table. So at -4, it's at 8. At -2, it's at 2. -1, it's at 0.5. At 0, it's 0. 1, it's 0.5. 2 is 2. And if I scroll down to 4, I should get 8 if it's mirrored correctly. And there we go, I get the 8. So now I just have to plot these points here. So -4, 8. -2, 2, -1, 0.5, 0, 0, 0.5, 2, 2, and 4, 8. Okay, now there's something to notice between these two graphs. This one right here, this one is wider than the parent. And this one is thinner than the parent. We call a quadratic that is thinner, we call that a stretch. Because we're like stretching it vertically. You're like taking a piece of string and you're stretching it up. So that's called a stretch. If it's wider, we call that a shrink. Okay? Stretch if it's thinner, shrink if it's wider. Okay? The other type of parent function is what happens when that thing in front of the x squared is negative. So that right there. See how that's a negative? That's going to affect our graph. So I'm going to go ahead and we're going to make another table, x and y. And I'm going to go ahead and put in my calculator this y equals -x squared. So I'm going to go back to y equals, clear it out, and I'm going to put -x squared. And we're going to see something interesting. Notice which way does this graph go? Now the graph goes down. So when we have a negative in front of our x squared, that makes the graph go down. And if I'm going to get my table of values here to save myself some time, I get -2, -4, -1, -1, 0, 0, 1, 1, 2, 4. Sorry, -1, -4. Okay, so that's my table for this. It's the same exact values, 0, 1, 4, only these are now negative. So when I go to graph, I've got 0, 0, -1, -1, 1, -1, -2, -4, and 2, -4. Now this is still a parent function because it doesn't have any values in front of the x squared, but it's concave down. And the vertex now, is the vertex at the top? Yeah, it's the very highest point, so this is a maximum. It's still at 0, 0. Your axis of symmetry is still x equals 0 because it's still going through the middle. Your y-intercept is still 0, 0, and your x-intercept is still 0, 0. Domain stays the same. I'm still going all the way left to infinity and all the way right infinity. But now my range is different. Now my range goes down forever, but it stops at 0. So these are properties of your negative parent function. So how's that going to look when we have the other equations we worked with? Well, they'll probably be very similar, only now they'll be upside down. So what I want you to try to do is on Desmos or on your calculator, try and graph these two equations. Okay, so you can pause the video, graph these two, get the table and calculator or Desmos, and plot these equations. So these are the two graphs you should have gotten with these coordinate pairs. Check your work. Make sure that you realize that the green one, negative 2x squared, that's a stretch from the parent function. It's much thinner. The second one is a shrink. It's much wider. So make sure we know the difference between stretch and shrink, and I've given you some guidelines down here below. Notice I've said that in all quadratic functions, the leading coefficient a determines whether it's concave up, positive a, or whether it is concave down, negative a. So if you've got negative in front, that means it goes down. If you've got a positive a, that means it goes up. Secondly, it also determines stretch or shrink. Cool enough is that stretch is when a is bigger than 0 or a is less than 0. For example, if you've got numbers like 2, 3, 5, or -2, -3, -5, those are stretch numbers. See how I've got a -2 here and it was a stretch? And on the other page, I had a +2 here and it was a stretch. So if you have positive whole numbers or negative whole numbers, that means it's a stretch. A shrink, on the other hand, is if a is between 0 and 1. In other words, if it's a decimal, like a decimal like 0.1, 0.2, 0.3, all the way up to 0.9. So notice that I've got 1/2. Half is between 0 and 1. Okay? So some things like 1/2, 0.5, 3/4, any 0.7, it is not something like 1.2, because 1.2 is bigger than 1. You probably won't see that, but it's not like that. A has to be between 0 and 1 for it to be a shrink. Okay? Notice that this is 1/2, and on the other page we had a positive 1/2, so that also made it a shrink. Okay? So we've covered a lot in this lesson, a lot of vocabulary, a lot of things to think about. I've given you some tools. So when you're doing your practice, make sure that you're really trying to absorb this language, because I'm not going to let you have a note card or anything like that on the quiz or the test. So really work hard on memorizing this language. Okay? Good luck.